Tell your friends to join fast till the strength is 68. We combine both the divisions till the strength is 68. Tell your friends to join fast. I'm sharing my screen. Yes, in last lesson, we have covered the hashing concept. So, indexing and hashing, these are the two techniques to search the data in a fast way. So, in indexing, we are using the index, and in hashing, we are using the hash functions, and we are applying that hash function on a search key. We are applying the hash function on a search key and creating the address. Is it? So there are two types of hashing, that is the static hashing as well as the dynamic hashing. In static hashing, the whatever is the bucket we are creating, its size is fixed. We cannot change that size. That's why it's called as a static hashing. We can perform insertion, search, delete operation using the hashing. So though there are two types of hashing, static as well as the dynamic. In static hashing, we can face the problem of the bucket overflow. The condition of the bucket overflow is also known as the collision. It is a fatal state for any static hash function, is it? So when the bucket is full and there is no bucket is available to store the new record, then it's called as a bucket overflow. Then to overcome this problem, there are two techniques. One, that is the open hashing as well as the close hashing. Okay, so in close hashing, it's also called as a overflow chainings. By using hash function, we are applying the hash function on a new record which we want to insert, and we are creating the address over here. And suppose the 105 address is already full, and then we are creating the duplicate of that one and linking to with existing one. So that means here we are creating the chain. So that's why it's called as a overflow chaining too. And next is the linear probing or open hashing. If the created address by using hash function is full, we are searching for the next free address to store the new record. So, and this searching goes linearly. That's why it's called as a linear probing too. Then the concept of the dynamic hashing, here we are creating the buckets according to our needs. We can grow or shrink the bucket size. So that's why it's called as the dynamic hashing. Now, let's see the comparison of indexing and hashing. So we are comparing the indexing and hashing in these four parameters, that is the storing of the address, performance, as well as the use for and memory management. Storing of address. In order indexing, addresses in the memory are sorted according to the key value called the primary key. Yes, the water is the memory or over there. These are the sorted one according to the key values, and for that we are using the primary key. And in hashing, addresses are always generated. It's get generated using the hash function on the key value. Yes, we are using the hash function and we are applying that hash function on a key value to create the address. And hash function is nothing but it's a mathematical formula, sign, cos, or anything logically you can apply to create the address mod. Okay, so now the performance in ordered indexing, it can decrease when the data increases the hash file. Performance of the searching, the decreases. It decreases when the data size get increased. It as it stores the data in the sorted form when there is any insert, delete, update operation performed, which decreases the its performance. Okay. And what about the hashing? The performance of hashing will be best when there is a constant addition and deletion of the data. However, when the database is huge, in hashing, the data size get increased, the hash file organization and maintenance will be costlier. Yes, using hashing, yeah, we can increase the performance. Though the data size is increased, it will give a good performance, but the maintaining and organizing the hash file is quite costlier as compared to ordered indexing. Then next parameter is the use of for. So the ordered index is preferred for a large retrieval of data, which means whenever there is a retrieval data for a particular range, there is a range in a specific sorted order is there, as well as the it quite in a within a range of data, then we can use the ordered indexing. But in hashing, there is a load limitations. This ideal method for when you want to retrieve particular record based on the search key. However, it only performs well when the hash function is on the search key. We are applying the hash function on the search key only. Okay. But when there is a large amount of data, we should prefer the hashing, but it's quite costlier too. Then the next parameter is the memory management. Yes, we also learned the clustering based indexing. In that, what is happening? There will be many unused data blocks, unused data blocks because of delete. We are performing the updation, deletion operation, and that data block can't be released or reused. That's why regular maintenance of the memory is required in the ordered indexing. But in hashing, though it's a static or as dynamic hashing method, memory is always managed. In static hashing, there is a bucket overflow problem is there, but still we are managing that bucket overflow problem with the open hashing as well as the close hashing. And in the dynamic hashing, there is no problem with the memory management because we are shrink or expand the bucket size according to the our need. So this is the comparison between the indexing and hashing. If you want to note it down, just note it down. So now come to the next point, that is the index definition in SQL. We learn n number of things related to the index, purpose of the index. Indexes are the special lookup tables. So how to create index using the SQL? That thing we will learn now. Indexes are special lookup tables. It is used to retrieve data from the database very fast, as we know that. And index is used to speed up select queries and where clause too. But it slows down the data input with the insert and update statement. Now, indexes can be created or dropped without affecting the data. And an index in a database is just like an index in the back of book. So how to create index using SQL? Let's see. As we create a table using the create table statement, create database to, if you want to create a database, then create database statement. Like that, to create index, we are using the create index statement. Is it? To create index for a specific table, we are using create index statement. It is used to create an index on a table, and it also allows the duplicate value. If you are using create index statement, then it allows the duplicate value too. Here is the syntax. Create as like a create table. When we are creating the table, now we are creating the index. So just write create index, and after that index name. On which table you want to create that index, the table name of that, and after that the on column which you want to apply that index. See over here example, create index. Here the name of the index is idx name, and assume that we are there is available person table already available. So create index idx name on persons table, and in that we are applying that index on last name and first name. Write down the syntax as well as the example how to create index. By using create statement, we can create index, view, table, database. Okay. So using create index, we can create a statement, but it allows the duplicate value. But sometimes you don't want the duplicate values, then to avoid that one, use unique index statement. Unique index statement. It is used to create a unique index on a table. It does not allow duplicate values. The purpose is so simple. Just if you are using create index, it allows the duplicate values too, but using unique index, it does not allow duplicate values. Here is the syntax. Create index, create unique index name on table name in bracket list of the columns on which you want to apply that index. Example, create unique index. Here website IDX is we are creating the new index on website table, and in that site name. Again, I am announcing one more time, the tutorial links from 1 to 5 are open. Submit all the tutorials as soon as possible. From Monday, it's again closed and not available. This is the last chance for you students. So submit it within a time, tutorial 1 to 5. Then the drop index statement, it is used to delete an index in a table. So suppose you want to delete the table, we are using the drop table command. It's a DDL command. So to drop index, to delete index, we are using the drop index and index name. This is the syntax. To delete permanently anything you are created as a schema, you can delete it using the drop command. It may be a database, it may be a table, it may be a view, it may be a index. Okay, this is all about our unit 6, that is the indexing and hashing. Let's start unit 7. Yes, our unit 7 name is the transaction and concurrency control. Listen carefully, concentrate here. Transaction and concurrency control. Yes, the main purpose of the database management is to organize, to arrange the data in very well format. Why it's required to organize in very well format? Because whatever we are performing any kind of transactions, it may be an insertion, update, delete. So it should happen smoothly, instantly. So transaction is the most important part of DBMS. Okay. So in this unit, we will learn the different concept like a transaction concept, transaction state, implementation of atomicity and durability, concurrent execution, serializability, recoverability, testing of serializability, concurrency control, how to control the concurrency. In that we will learn the log based protocol, then log, granting of logs, two-phase locking protocols, timestamp based protocol, as well as the deadlock handling. The content of this chapter is little bit more, that's why it's somewhat lengthy. The concept of theoretical, though the concept of the theoretical, but logic is behind that for each and every concept. These are the very interesting concept. Because day-to-day life you are performing any kind of transaction, usually using Google Pay, Phone Pay, online banking, reservation systems. So what are doing? You are doing the different kinds of transactions. And for performing the transaction, there should be account should be there. So you are dealing with the some kind of user account and you are performing the transaction. So it's quite interesting as end you are handling. But what is the logic behind how to that uh, going internally? These things we will learn. So transaction concept. A transaction is a logical unit of work of database processing that includes one or more database access operation. It's a logical unit of work of database processing. And within a transaction, one transaction, one or more database can may be included. A transaction can be defined as an action, or it may be a series of actions that carries out by a single user or application program to perform operation for accessing the content of the database. Yes, while we are performing the transaction, one or more database access operations may include. And at a time, we can perform single or more operations, series of actions, but this is carried out by a single user at a time or single application program. Single user can perform the multiple actions, but at a time, only one user, single user, or application program. So transaction processing system execute database transaction with a large database and hundreds of concurrent user. For example, railway, air reservation systems, banking systems, credit card processings, stock market monitoring, supermarket inventory, checkouts, and so on. There is a no end of that these kind of list. It day by day it goes increase. So operation can include retrieval of the data. Which kind of transaction we can perform? Retrievals of the data, reading, then insertion, that is the writing, we are making updation, then deletion, modification. A transaction must be either completed or aborted. There are few concepts. We are usually using these concepts, but technically we are learning these concepts now. Okay. At a time, एक single user and series of actions perform करू शकतो. या transaction मध्ये n number of more than one database at a time येऊ शकतात. परत जे काही आपण ट्रान्झॅक्शन करत आहोत एका अकाउंट वरून दुसऱ्या अकाउंटवर, तर त्यावेळी जे काही ऑपरेशन आपण ते आयदर कम्प्लिटेड पाहिजे, फुल्ली कम्प्लिटेड पाहिजे सक्सेसफुली, और इट शुड बी अबॉर्टेड. म्हणजे आयदर ऑल और नन. Okay, these are the basic concept of the transactions. See the example. Suppose an employee of a bank transferred 800 from X account to Y account. One employee want to bank transfer 800 from X account to Y account. Ma'am, it's so simple. We are performing it daily, but what's happening internally? This small transaction contain several low-level tasks. Which are those? Let's see. Yes, to perform the transaction, at least two accounts are needed. Suppose here is the X account and here is the Y account. At X account, at the end of the X account, to perform to transfer from X to Y, first we have to open the X account. This is the first task. First we have to open that account. Let's, what is the balance? X balance. Take that balance. Then your old balance, and whatever is your current balance, transfer it into the old balance, and after that old balance minus 800, because we want to transfer that 800 to the another account. So first minus that 800 from X account, and after subtraction, store the new account balance. This is the third step. Then now new balance stored in the X dot balance, that is now it's the current balance, and close this account. This is happening at X account end. Now what is happening in Y account? Same. Open the first Y account, check the balance, then update the balance, old balance with plus 800, and now store the updated balance in the Y's account, and after that close that account. So just this single transaction took place, the total 5 uh, action, small actions at X account and 5 tasks at Y account. Okay, just note down these points. Now let's look to the properties of transactions. Though we are performing the transaction successfully, behind that each and every transaction should maintain the some properties. These are the 4 properties. That properties also called as the acid properties. Which are those? Let's see. A transaction must have the following 4 properties called acid properties. Acid is the short form of these 4 properties, or we can also say that the acidity of a transaction to ensure that the database remains stable state after the transaction is executed. See, database remains stable तो हलतो का कुठे फिजिकली नाही पण लॉजिकली सपोज जर तुम्ही काही ट्रान्झॅक्शन करत असाल आणि डेटा जर अपडेटेड त्याच्यामध्ये नसेल तर समटाइम्स तुम्ही विथड्रॉ कराल किंवा काही अमाऊंट ट्रान्सफर कराल आणि ते अपडेटेड नसेल तर व्हॉट्स द यूज ऑफ दॅट ट्रान्झॅक्शन. तुम्ही कधी लॉस तुमचा कधी प्रॉफिट होईल पण मोस्ट ऑफ द टाइम लॉसच होईल. सो after performing, before as well as the after performing the transaction, that should be a stable. It should maintain the current updates. It's most important. So here acid is A for atomicity, C for consistency, I for isolation, and D for durability. Let's see each and every one individually in detail. First one is atomicity. The atomicity property says that the property of transaction require that all the operation of the transaction be completed. It should be completed, and if not, the transaction is aborted. The transaction should be performed all successfully or nothing. That's why this property is called as a all or nothing property. It should perform successfully fully, or if executed partially, and if something happened wrong while a transaction is going on, then it get aborted. So and it saved as a nothing is happen. So atomicity said that it performed fully, all, or nothing. And this is responsibility of or duty of the recovery subsystem of a DBMS to ensure the atomicity. In the event of the system crash in the mid set of the transaction execution, the recovery techniques undo. If any system crash or power failure is happening while transaction in going on, then the recovery techniques undo. It goes back, it roll back all the effects of the transaction on the database. Okay, that is the atomicity. Now the consistency, our database must remain in a consistent state. It should be a stable after the any transaction, any single or series of the transaction, or before the transaction too. It should maintain the consistency. जे काही तुमचा डेटाबेस आहे त्याच्यामध्ये काहीतरी सातत्य हवंय किंवा एकसारखेपणा हवा आहे, जे काही त्याच्या रिप्लिकाज असतील वेगवेगळ्या ब्रांचेस मध्ये वगैरे, तर दॅट शुड बी अ कन्सिस्टंट. ओके, एकामध्ये एक आहे, दुसऱ्यामध्ये दुसरा डेटा आहे, सेम रेकॉर्डचा, तर तसं नाही. दॅट शुड बी अ कन्सिस्टंट. A database may remain a consistent state after any transaction. No transaction should have be adverse effect on the data residing in the database. If the database was in a consistent state before the execution of the transaction, it must remain the consistent after the execution of the transaction as well. Okay, so though we are performing n number of transactions, so the database from one consistent state to another consistent state, it must transfer from the one consistent state to another consistent state. That is about the consistency. Then the next property is the isolation. Is there any doubt till now? Is there any doubt?
No, ma'am.
Okay. Isolation. In a database system where more than one transaction are being executed simultaneously, of course, in a parallelly, the property of isolation states that all the transaction will be carried out and executed. If it is the only transaction in the system, no transaction will affect the existing of any other transactions. It should not affect, though the n number of transactions going on parallelly. Yes. एक बँक सिस्टीम आहे, बँक अकाउंट आहेत, सॉरी बँक डेटाबेस आहे, त्याच्यावर ऍट अ टाइम सायमल्टेनियसली एन नंबर ऑफ ट्रान्झॅक्शन चाललेले असतात, पण एक ट्रान्झॅक्शन दुसऱ्या ट्रान्झॅक्शन्सला इफेक्ट करणार नाही. That is nothing but it maintains the isolations. The fourth one is the durability. The database should be durable enough to hold all the latest update even if the system fails or restart. Okay, मधूनच सिस्टम फेल झाली किंवा रिस्टार्ट झाली, पण जे लेटेस्ट अपडेट आहे that should be durable. If the transaction updates a chunk of data in a database and commits, then the database will hold the modified data. म्हणजे सपोज जर काही झाले असतील ट्रान्झॅक्शन्स, तर इट शुड होल्ड द मॉडिफाईड डेटा. अँड इन वाईल वी आर परफॉर्मिंग द ट्रान्झॅक्शन्स, काही सिस्टम क्रॅश झाला तर आजीची जी स्टेट आहे त्या स्टेटवर तो रोलबॅक व्हायला सक्सेसफुली रोलबॅक झाला पाहिजे. If the transaction commit but the system fails before data could be written on to the disk, then that data will be updated once the system springs back into action. Okay. See, this is the diagram. In this diagram, you can see at a glance the acid properties in a DBMS. I am explaining all these properties thoroughly. Still, here you can see at a glance. Atomicity means the entire transaction takes place at a once or doesn't happen at all. Hmm? Consistency property says that the database must be consistent before and after transaction 2. Isolation property says that multiple transaction occurs independently without interference with each other. Okay, though the transactions occur parallelly, that should be occur independently. They should not interfere with each other. And durability, the changes of a successful transaction occur even if the transaction failure occur. Okay, this is all about the properties, acid properties. Today we start the unit 7. We have started unit 7. In that we have learned the transaction basic as well as the acid property. If is there any doubt, let me know.
No, ma'am.
What about A division? Is there any doubt?
No, ma'am.
Okay. We are stopping here today. B division, attendance please. B division. Roll number 1. B division, attendance. Roll number 1. 2.
Present.
3.
Present, ma'am.
4.
Present.
5.
Present.
6. 7. 8.
Present, ma'am. 7.
B division, attendance please. It's not A division. 8. Roll number 8. B 8. 9.
Present.
10. B 10. 11. 11. 12. 13.
Present, ma'am.
14.
Present, ma'am.
15.
Present.
16.
Present.
17. 17. 18.
17.
Okay. 18.
Ma'am, 18. Present.
19.
Present.
20.
Present.
21. 22.
Present.
23. 23. 24.
Present.
25.
23 present.
Okay. 25. 25. 26.
Present.
27.
Present.
28.
Present, ma'am.
29. 29, 30,
Present.
31,
Present.
32,
Present.
33, B 33, 34,
Present.
35,
Present.
36,
Present, ma'am.
37,
Present.
38, 38, 39, B 39,
Present.
40,
Present, ma'am.
41, B 41, 42, 43, B 43, 44,
Present.
45, 45, 46,
Present.
47,
Present, madam.
48,
Yes, ma'am.
49, 49, 50,
Present.
51, 51, 52,
Present, ma'am.
53, 54, 55, 56, 57, 58, 59, 60, 61, B 61, 62, 62, 63,
Yes, ma'am.
64, 64, 65, 66, 67,
Present.
68,
Yes, ma'am.
69,
Present, ma'am.
70, 70, 71, 71, 72. Okay, A division. 1. Yes.
Present, ma'am. B6.
Okay.
11, ma'am. 10, ma'am.
10, 11. Okay. Anyone remaining from B division?
Ma'am. B33.
Okay. Fine. A division attendance. 1,
Present, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5,
Present, ma'am.
6,
Yes, ma'am.
7,
Present,
8,
ma'am.
8,
Yes, ma'am.
9,
Present, ma'am.
10, 11,
Present.
12,
Present, ma'am.
13,
Yes, ma'am.
14,
Present, ma'am.
15,
15.
16,
Yes, ma'am.
17,
Yes, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Yes, madam.
22, 22, 23,
Present.
24,
Present.
25. Okay. 25,
Present, ma'am.
26,
Present, ma'am.
27,
Present.
28,
Present, ma'am.
29,
Present, ma'am.
30,
Yes, ma'am.
31,
Yes, ma'am.
32,
Present,
32,
ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36,
Present.
37,
Present.
38, 38, 39, 40,
Present, ma'am.
41,
Present, ma'am.
42,
Present, ma'am.
43,
Present, ma'am.
44, 44, 45,
Present, ma'am.
46,
Yes, ma'am.
47, 47, 48,
Present.
49, 49, 50, 51, 52, 53,
Yes, ma'am.
54, 55,
Yes, madam.
56,
Yes, madam.
57, 57, 58, 59, 60, 61, 62,
Yes, ma'am. 62.
okay,
70.
Ma'am, 62.
okay, 63,
Ma'am, present.
64, 64, 65,
Present.
66,
Yes, madam.
67,
Present, ma'am.
68, 68, 69, 69, 70,
Yes, ma'am.
71, 72,
Yes, ma'am.
okay. Anyone remaining now?
Madam, B59.
B59, okay. Anyone?
Ma'am,
Madam, A66.
Wait,
A66.
A66, okay,
Ma'am,
next,
53.
B33, yes, mark your presenting. Next,
A54.
A54, yes,
Ma'am,
okay. Next,
B61.
B61, yes, it's already marked present.
Thank you, ma'am.
Hello, ma'am.
Yes,
A61.
A61, yes, Is there anyone remaining now?
B6, ma'am.
B6.
6.
Yes, I mark you are presenting.
Ma'am, B23.
B23. Yes, next. Okay. Thank you, all of you.